Hi again, everybody. My name is Greg Anderson, and today I'm out in the family playhouse to talk about electricity. Okay, and more specifically, this box right here. This is an Anker 535 portable power station, or in parentheses, it says Powerhouse 512 watt hours. Now, why would I want something like this? Because it's cool. I've actually been looking at something like this for a long time, and I'm kind of glad I didn't buy this 3 or 4 or 5 years ago when I first got interested, because I think the new model has a lot of things that make it more attractive than the model that I would have bought, again, 3 or 4 years ago. So you can find a similar device from a lot of different manufacturers and a lot of different brand names. So Bluetti is a very popular one. Jackery, EcoFlow, Goal Zero. I know I'm leaving out others, maybe some kind of startups, some brand names we've never heard of that are still going to be just about as good as this. I went with Anker because I've had other Anker devices, some smaller devices, and I really liked their general design and just a few things about this that appealed to me more than the others that I was considering. But you will find many devices very similar to this under different brand names, and probably they're all pretty good. But let me tell you one thing that's kind of the major point of this that I really like, and that makes me glad I didn't buy this, 3 or 4 years ago, and that is the kind of batteries that are inside of this. So let me just talk about what is this thing. Okay, it's a battery with some built-in various kinds of outputs built into it. So a self-contained little power station, if you will. And all you have to do is charge it up. You can charge it either by plugging it into the wall in a normal, AC outlet in your house, or you can power it by plugging it into the DC output in your car or your RV, just that, little round receptacle, just plug it in there and charge it up that way. Or you could get solar panels, or maybe just one solar panel that would charge this thing up, and you can do it that way. This one didn't come with a solar panel. There may be some package deals where you can buy it with a solar panel included, but I decided to do something else. I got a third-party solar panel at Harbor Freight, of all places, and it works really well, and it was a good deal. And the other thing about that is it was right there. I didn't have to wait for it to be shipped to me. I could just pick it up in the store and take it home and start using it immediately. So that's one of the advantages of Harbor Freight. The solar panel I got, again, looks pretty good from Harbor Freight, and I'll tell you more about that maybe in another video. But for now, let's just concentrate on what this box does. So this has a pack of lithium iron phosphate batteries inside of it. Now, the older versions of this would have had lithium ion batteries in them. And I don't know all the ins and outs of the chemistry in there and what's involved, but what I do know is that typically lithium ion batteries last about 500 cycles of full charge and discharge before they start to wear out, kind of lose their capacity to hold a full charge like they did when they were brand new. So that's why if you've got an iPhone or any other smart device like this that probably has a lithium ion battery built into it, after about 500 charge and discharge cycles, it starts to, lose that battery power. And for most folks, that's about 2 years. So you figure, 5 times a week for a couple of years, that's about 500 times. And so that's why typically a lot of people think, about 2 years before your battery starts to go out. Now, in the case of this iPhone, I found the Zag store downtown. There's a really nice guy there who did some work on changing a cracked screen for me. He did a great job, and he does it every day, and he has all the tools and the expertise. And so if it costs me a few dollars more than it would for me to do it myself, I'm happy to pay that guy to change out the battery in this phone. And I've had this phone for more than 3 years, about 3.5 years already, and it works okay. Probably within the next 6 months or maybe a year, I'll need a new battery for this phone, and I'll just take it down to that guy and get a new phone battery, and he can open it up and put it back together, make it look really nice. Now, with this thing here, though, this is not lithium ion. This is lithium iron phosphate. And sometimes if you see the specifications on one of these, it'll spell it out with kind of the abbreviations from the periodic table. So lithium iron phosphate, or so it looks like LiFePO or LiFePO 4 batteries. So that's a different kind of battery that still based on lithium, I guess. But but the key to the lithium iron phosphate battery is instead of 500 cycles, it's more like 2,500 or 3,000, or with some of them like 4,000 cycles of full charge and full discharge before they lose any significant ability to hold a charge like they did when they were brand new. So, let's say it's 3,000 for this guy. Okay, instead of 500, it's 3,000. So that means instead of 2 years, it could be 12 years before this battery starts to go. And that's talking a full charge and discharge cycle. And unlike my cell phone, which I basically, discharge it every day and charge it back up again, this one, might go for like a week, that I'm really not going to use it all that often like I would with the phone. So we're talking well over 10 years of use on this before that internal battery starts to go bad. And so they don't really make a battery replacement for this. They don't make it easy for me to change the battery on this guy either. But I think, in 10 years from now or 12 years from now, whenever this battery goes bad, by then I'll probably want to buy whatever is new at that point. Okay. So whatever the electronics part of it here and the battery that's inside of it, all that technology is going to be so much better anyway. So I'm happy to have this for 10 years or 12 years or whatever, and just buy a new one after that. And even if you figure 10 years, then, and this cost me, you can get these for about $500. So that's like $1 a week, for 10 years. The only disadvantage of that financially is you're paying for the electricity up front. If I were just to take, something like this and plug it into the wall, I pay as I go as far as the electricity. I pay the power company for whatever electricity I used that week or that month, right? But with this one, it's like I've paid for the electricity in advance, especially since I have the solar panel. And so now it's just over the next 10 years or more, I get to use the electricity I already paid for. So it feels like it's free. Okay. And that's what's kind of fun about having something like this. So some of the boxes you're going to find from other manufacturers may not have the lithium iron phosphate batteries. They may have the older style of lithium ion batteries inside. And if it were me to buy this all over again, I would definitely go for the lithium iron phosphate batteries instead of lithium ion. And that may determine some of the brands and manufacturers that I deal with if I'm going to insist on lithium iron phosphate. Now, the other thing about this box is, it's a 512 watt hour battery. And that's pretty good. Basically what that means is if I had something that uses 512 watts, I could run that for an hour off this before it would, drain the battery completely. So to simplify the math, let's just say it's a 500 watt hour battery. So 500 watt device, run this for 1 hour, and then I'm out of power in this one. But if it's a 100 watt device that I'm running off of this, it would run for 5 hours before the battery would be depleted here. And that makes it pretty useful for me. Certainly there are some high draw devices, right? Like if I wanted to run a hair dryer, this couldn't do it, because hair dryers typically are like 1,500 watts or maybe 1,800 watts. And this just simply would not power a device like that. It's got some protection built in so that if I tried to run a hair dryer off of this, it would just shut down. Power tools, certain power tools, maybe the specification is in amps instead of watts, but it's easy to figure out. Let's say I've got a 10 amp power tool, and that's 120 volts and 10 amps. So multiply those together and I get 1,200 watts. So my 10 amp power tool is 1,200 watts, and that is still too much for this to handle. It has a built-in inverter here so that I could take regular household, alternating current devices and plug them in here but it's made to only put out about 500 watts. Maybe if there's a little bit of a surge as the device starts up, it could handle the surge of over 500 watts. But when it settles back into the continuous power, it's looking for 500 watts or less. So that's a consideration. So a very useful box for me. Now, I don't go camping all that much, and I don't usually go out in the middle of nowhere and need to recharge my drone several times while I'm out there. But if I did, I would need this, and it would work really great for that. Also, if you have a power failure and you want to run just a few devices while the power is out, here you go. You can plug a TV and a radio and charge up all your mobile devices on this while the power is out, and even have a little light there to help you while the power is out. So a great thing to have as a backup for emergencies. Great thing to have if you're out and about with electronic devices and you don't have an easy place to plug in. Just use this, or camping. So it's not for everyone, but it may be more handy than you think. Now this one, I waited for a deal. This one, typically they want to sell it for $599, and that's very similar to the prices I've seen on from other manufacturers of basically the same kind of box with the same kind of specifications. So about $600. Typically, a lot of times I'll see coupons for at least $100, taking it down to about $500. Shouldn't be that hard lately to buy this exact thing for about $500. I happened to buy this when the coupon was worth $150, so I got this for $450. And that may seem like a lot, so you judge that and what you want to do about it. There is one that's about half this. Well, it's about half this size, about half this much power, and about half as many outputs. It still has a variety of outputs, but so it's going to only last about half as long when you're using that one. It costs about half the price. There's also one that's about double this capacity, so it's bigger, it's heavier, it has a few more outputs, and so it would last longer. And you could plug something that uses 1,000 watts into the bigger model of this, but it would also cost you more like $1,000 to get that one. So I thought this was a good compromise. I think the one smaller than this really wouldn't be that useful for me, with only the ability to put out about 300 watts. And the one bigger than this, I think it would be great, but I just wasn't ready to spend that much money. Part of what I was trying to do was kind of a proof of concept. I thought I would like this device, but I wanted to prove it to myself. So I didn't get the full-blown, spend $1,000 or more to get that really beefy, powerful one. But I didn't get the smaller one either. I got this one, and the good news, bottom line, is it does what I want it to do. I have very little to complain about on this one. And basically, the only thing I'm complaining about is it doesn't have more power, which that's my fault because I didn't buy the one that had more power in it. But it really works well. Really a good design, good solid thing. It does what I want it to do. So that's the bottom line. If you're going to get one from Bluetti or Jackery or one of these others, just kind of do your research. And again, the only thing I would worry about would be what type of batteries they're using. I'm sold on lithium iron phosphate batteries. Now, how do you use this thing? Okay, first of all, you charge it up. And it came with two ways to charge it. It came with two cords, power cords. This one, you just plug into the DC output in your car or your truck or whatever your vehicle is. And then this just plugs into the back of here. It's some people call it a 7.9 millimeter barrel, or in this case, it's called an 8 millimeter barrel DC connector. And it just plugs right in the back. Simple as that. So you got power coming in from there, going into there, and it charges it at about 100 watts. So in your car, your vehicle, maybe 100 watts is a lot to draw from your vehicle's power system. So not all vehicles maybe can handle that, but if your vehicle can handle that, then 100 watts, and there you go. So if it's completely drained, you're talking about 4 or 5 hours to get it completely charged up at that rate of 100 watts. Now, this also came with the wall adapter that's made to just be plugged into the wall. Regular AC power goes through here, and on the other end again is that DC barrel that just plugs into here. And again, charging it at about 100 watts, somewhere between 100 and 120 watts. And it'll charge up reasonably fast in that configuration. Or the other thing you can do, you could use solar panels as long as the output of the solar panels matches this. So maybe your solar panels don't have this exact thing on the end to plug into here, but you can get adapters, and it's pretty simple to do that. Now, the solar panels you want are going to be, somewhere between 12 and 28 volt output into here. And again, it's only going to take about 100 watts. So if you got a really beefy solar panel that's putting out 500 watts at 48 volts, you probably fry something in there. So you don't want to do that. But I have the Harbor Freight panels, and I got a couple of them. They have capable of maximum output of 200 watts at somewhere between 12 and 20 volts. So if I plug those into here, it's not going to charge it any faster than about 100 watts. It'll just kind of top off there. But the nice thing about that is 200 watts. If it were a full bright day and those things were putting out maximum power, those solar panels, 200 watts, as long as it's the right voltage that's within range here, it'll kind of cut it off and cap it off and just charge it at still about 100 watts, maybe up to 110 watts or so, charging this up. It won't overdo it with those two panels. But the thing about using two panels as I have them configured in a parallel configuration as far as the wiring, if a cloud comes by and the panels are putting out only 50 watts each, well, then this thing is still getting 100 watts. So that's kind of why I decided to play around with two. Plus, I had an extra coupon for the Harbor Freight panels, and plus I was experimenting because I wanted to make YouTube videos for you to watch. So that's why I tried to do two Harbor Freight panels, even though it's more than I typically would need for this. So you got the solar panel option, and once again, I've purchased the solar panels. I got them. That expense is done. I've purchased the power in advance, is kind of what that feels like. So from now on, since that's paid for, all the electricity I get from it now seems like it's for free. So that's kind of fun. And so I've taken some advantage of that. Since this has a power inverter built in there, I've taken some devices that I would normally just plug into the wall and decided I'm going to charge them from now on using the sun to charge this. And I've got off-grid power to power things like the batteries for this camera. I've got a little battery charger that normally plugs into the wall. I plug it into here, and ta-da, my camera is now solar powered, as it were. I've got an electric lawnmower that uses batteries. And so I charge the batteries by plugging the battery charger into here, and now I've effectively have a solar powered lawnmower. So any of those devices, as long as they're, less than 500 watts, there I go. And the nice thing is, this has a kind of a pass-through power thing. So what happens is, while I'm charging it up with the solar panels, I can at the same time be taking output from any of these places here. So, the battery gets in between there and does a few things, but for the most part, I could, if the battery were fully charged or close to fully charged, I could be putting my solar power into this and having output at the same time. And then it could feel like I was, charging up my camera batteries and, powering other things without cycling the internal battery in here very much. Okay. So it really does feel like I have solar powered, iPhone now. I have a solar powered lawnmower, solar powered camera. And it's fun to have that. And I wanted to experiment with that, and I wanted to have some fun with that. Now let's talk a little bit more specifically about the outputs on here. I want to just show you this display here. If I push that button there, it comes on, showing me that there's 82% battery life still left in the battery. And then down here, I didn't show you this before, but this is a light. And if I turn that on, it's showing me that the light is using 4 watts of electricity, and that it could run for 96 hours if I'm drawing this much electricity off of it. So it's kind of nice to know. It's got a little countdown there for you. If I press and hold the light button Here, it'll blink. So a nice little SOS light there. I suppose you could get someone's attention with that if you're in trouble. Put this in the back of your car, a back window, or on the ground behind your car if you're in trouble, and get someone's attention with that. And that uses even less electricity if it's in that blinking mode. Now this button here, you see it has a little bit of a light in the middle of the button to tell that I've activated the car socket. And so anything that I would normally plug in to a car, I could plug in there. And right now it's not drawing anything, but that's something that's available, and you just turn that on or off. Now these USB outputs, you don't turn those on or off. It's just this box can automatically determine if something is trying to draw power. So if I plug in my iPhone there, for example, you can see that it's drawing about 8 watts to charge up my iPhone that's almost drained at this point. And I could do that for over 41 hours if I needed to. So that means, if I were just charging iPhones off of this thing, I could probably charge, I don't know, a dozen times using that right there. So yeah, that's what you get. And this display turns off after about 30 seconds. So every now and then I just push the button to keep that going. But normally I don't need that on all the time anyway, because I plug something in and there I go. Okay, so what else do I have here? Okay, it's settled down to just 6 watts to charge the iPhone. So it'll, doing okay there. Now then over here is where I turn on the inverter. So let me unplug the iPhone and we'll get a nice pure reading here. Now the inverter with nothing drawing off of it, okay, it's still showing that there's 16 watts. So it does require some power just to run the inverter. That's why you want to maybe turn on the power saver mode if you don't want to run it down too much. So even with nothing going, 68 hours, you're going to drain the battery anyway. But let's plug something in. This is my charger for my camera battery. So as I charge, I plug that in, and there's no draw right now, but let me put a battery on the charger. And now it's going to show me, of course, that it is drawing power to charge up my camera battery. And it's showing that it's about 33 watts, 32 or something in there. So again, that's the inverter itself plus the amount of power being drawn from the battery. So, even with this, it could go almost 13 hours. And by then the battery will be charged anyway. That's something I can do. So anyway, and the other thing, let me just, for the fun of it, I'll plug in the battery for my lawnmower. And now you can see that together, the camera battery and the lawnmower battery chargers, each doing their thing. Now I'm up to 125 watts, 126 watts or so, drawing off of there. And I could do that for 3 hours and get that going. But one thing I can do also while this is happening, though, I'm going to reach around the back and I'm going to plug in the battery charger that's plugged into the wall behind me. So if I've got the battery charger going, now it's showing me that the battery charger is bringing in 107 watts, and the output from these 2 other batteries that are coming off of this inverter is 127. So 107, 127. So actually, the net draw from this battery is now just 20 watts, and it's showing me that it can continue to do this for about 14 hours. So I'm in good shape here. And this is something I would normally do if I were outside. I would plug in my solar panel here and get just as much power coming in off of a solar panel. And this would be a completely off-grid system where I could charge this. And as soon as those batteries are charged up, it won't draw as much here, but I'll keep charging the battery with the solar panels. Anyway, it gives me all this information right here on this easy-to-see display, which is kind of fun to have that, that I can monitor as I go and see what this box is doing. Also, I should mention, when you're not drawing energy from this thing, we're only charging it, then that little readout will show you how much time it's going to take to complete the charge, rather than showing you how much time remaining until the battery is depleted. So, and that's a kind of a nice feature right there. And then there's a little switch here on the inverter that changes how the inverter acts by just a little bit. But you've got 4 outlets here, and you'll see that they're polarized, which means one side is a little bit wider than the other. So if you've got a polarized 2-prong thing you're trying to plug in there, okay, there's only one way to plug it in. Or if it's this 3-prong guy, there's only one way to plug that in. And you see that there's a space there, just a hole for that ground part of the plug to fit into. It actually doesn't connect to anything, but it's available there. And when I do that, then the plug underneath it, you couldn't do two of those, one right above the other. You could do two next to each other, but not one right above the other, because there's not enough room for two of those ground prongs to go in there. But they are there. And, as long as you're not drawing too much power, I guess you could put a power strip on one of these and run a few things off of a power strip. When you turn on the inverter, it's going to draw a little bit of power just to power the inverter. Plus, there's a little cooling fan that comes on, and it's really quiet. I don't even know if you can hear that. It's really quiet. But if you start to draw too much, that cooling fan will turn itself up and start making a little bit more sound, depending on how much you're drawing out of it, how much this thing needs to cool itself. But that was one complaint I saw about the Bluetti device, was that as soon as you turned on the inverter, the cooling fan turned on and was kind of a little bit too noisy, even when there was no real load coming off of it. Now, I don't know if that's still true, but that's one of the reasons I went with Anker. Then over here is a switch called power saving. And what that basically does is it kind of monitors the output on this so that if you're charging up something and that thing finishes charging and basically the charger shuts itself down and is not drawing any power because it's done doing what it's wanted to do, this will kind of sense that, and it will automatically shut off the inverter when there's nothing being drawn off of it. Now, that could be a little tricky with devices that really don't drain this very much, don't draw a lot of power, like maybe a CPAP machine. They say, if a CPAP machine seems like it's drawing very little electricity out of this, you should turn off that power saver so that this is always on, even when the CPAP machine seems like it's not drawing enough power. This is not going to shut that off. So, I tend to leave the power save mode disabled on this because I'm usually monitoring this pretty well anyway. So just again, you've got the button to enable and disable that inverter. Now, what is an inverter? Okay, this battery is using direct current or DC power. And when you're coming off of solar panels, that's also DC power. This charger, the adapter is feeding DC power into here. Everything is DC power. But when you want to plug in your normal devices that you normally plug into the wall, you need AC power or alternating current. So this inverter that's built in is making that change for you from DC to AC with the proper voltage. And it works really, really nice, really simply, and you really don't have to worry about it. As you're looking for these devices, most of them, I think everyone I've seen from the different manufacturers says it's a pure sine wave inverter built into it. What does that mean? Pure sine wave. The other kind is usually called a modified sine wave inverter. So what's the difference between those? Well, a pure sine wave, let's put it this way. The alternating current is alternating, like the two wires, for example, would be alternating between positive and negative at 60 cycles per second. So it's a really fast alternating there. If you have a device that can measure that, and maybe an oscilloscope that can actually show you that transition between the two states, as it goes between positive and negative. If you have a device that can show you how that's operating, you should see a very smooth wave. Now, most of us don't have a device like that. Most of us don't need a scope to look at that. But imagine if that wave, rather than being a nice smooth transition between positive and negative, is more of a stair step, kind of a jagged edge, or even a more severe, straight up and down kind of thing that you would see on the graph. That transition should be smoother, and that's what a pure sine wave can do. A modified sine wave would be that stair step thing, or something like that. So if you were to go to, say, Harbor Freight, and you wanted to buy an inverter that you're just going to use. You're going to install it on your truck and you're going to drive around. You're going to run your power tools or whatever off of this beefy inverter that you bought. You're going to see some are pure sine wave and some are modified sine wave. And the pure sine wave is going to cost a little bit more. It used to be the price difference was more significant. Now it's not that significant. So if you're getting a modified sine wave inverter, some of the devices you plug into that are going to be more sensitive to that non-smooth transition between positive and negative. So, and if you listen to some people, it's like they say that certain really sensitive devices could even be damaged if you plug them into a modified sine wave inverter. So your devices won't run as well. They might be damaged. They might not be as efficient. They might generate more heat than they should. So basically, if I were to give you some advice on the inverters, just go with a pure sine wave inverter. If it costs a little bit more, just pay that and just have a pure sine wave inverter. And you don't have to worry about what you use with it. If it's a pure sine wave inverter, it'll run just fine. And like I said, if you're getting one of these devices that's all self-contained and has an inverter built into it, everyone I've seen advertised, it's already a pure sine wave inverter. So you just don't have to worry about that. All right, so bottom line for me, I've been curious about a device like this for a long time, and now that I have it, it does what I want it to do. And I don't know how much more happy I could be than that. I got what I wanted to get with it. So it's kind of a proof of concept. This is great because it has everything built in except solar panels for a self-contained power station. And I can add the solar panels, and I already have. So as far as the battery, the charge controller that's going to properly take the input to charge up that battery, it's all built in. The pure sine wave inverter, all built in. All the outputs I want, all built into one device. That's very convenient, very portable. This is a little bit heavy. It's about 17 pounds, 16 or 17 pounds. And it's not that bad. I guess if you had to carry it, on a 10-mile hike, you might not like it. Again, they've got the one that's about half this much power, so it's probably a little bit lighter. You got the one that's about double this much power, and that'll be heavier. But this was right in between, right about where I wanted it, and it's working great for me. I've had it for a few weeks already. I'm sold. I like it. I'm glad I have it. I thought to myself, maybe I'll look for a sale and I'll go ahead and get the bigger one, the one that has double this capacity and costs twice as much. The next time there's a special sale or something. And I thought, no, I'm going to think this through. Because what I really would love to do, if I'm going to play and experiment with my electricity and where I get my electricity, wouldn't it be great to have an off-grid system, completely off-grid, for this building that I built? This family playhouse. It's about 200 square feet. What if it were completely self-contained as far as electricity goes? And I didn't have to run a line from the house out to here to power the place. And if I'm going to start thinking about spending money on devices like this that could power this building, why don't I take the next step and design a good off-grid solar panel system? So that's what I'd like to do coming up in the near future, and we'll see. I'll document what I do here on YouTube as I move along with that idea. What I'm going to need for that is some solar panels, enough solar panels that I can put on the roof of this and permanently install them on this roof. Then those solar panels will have to feed their electricity into a charge controller. That charge controller will send that electricity properly, managed into a bank of batteries, or maybe just one really good beefy battery. That battery is going to then send the power out to a pure sine wave inverter, which then I'm going to plug into the electricity that comes into here. The electrical connection comes into here. So a few components, I can maybe find a kit where everything comes, or I could, kind of assemble this from different sources and eventually get what I need. But basically, it's a supersized version of this with individual components that even if a component were to fail for some reason, I could trade it out, or, I could maintain it in the future. I could upgrade things like batteries or whatever. So that's what I'd like to do. And this is kind of the catalyst for that idea to proof of concept. Yes, it works. I know now from this, now I can take the next step and do an off-grid cabin type of thing here for this playhouse. So that'll be fun. And of course, as I move forward, I'll tell you all about it. And another thing, I'm going to make a video soon, and I'll tell you more about the solar panels I got from Harbor Freight that are going to be very similar to solar panels you can get from other sources as well, that I use to charge up this thing. So it's a fully off-grid power system just with this already. So anyway, that's all coming up, and I hope you'll be back and we'll talk about all that, and give me some ideas in the comments if you've done some cool things with electricity and solar panels and batteries at your place, and we'll have some fun with this. So come on back to this very YouTube channel.